Hello everyone, welcome to ACE Engineering Academy and ACE Online. This is Ramesh Pabba, faculty at ACE Engineering Academy. In this session, we are going to concentrate on score booster series, right? Measurement subject, we are going to cover NAT, numerical answer type questions as well as MSQ questions. Let us solve the questions. The question here is, a three-phase 500 volt motor, a three-phase 500 volt motor has the power factor of 0.4. So power factor is given 0.4. Two wattmeters are connected to measure the input. Indirectly he has mentioned that 2 wattmeter method is used. They show the input to be 30 kilowatt. So input power is 30 kilowatt. Find the reading of each instrument. Find the reading of each instrument. Guys, the moment you see the question, you keep on solving. After you are getting the answer, kindly check with my answer. For that purpose, I have given the values here just for clarity purpose. Okay, let us solve the question here. He has given that total power is 30 kilowatt. Total power is 30 kilowatt and power factor is 0.4. Power factor is 0.4. From this you can calculate phi value. Phi is equal to cos inverse 0.4. After this you can calculate tan phi value. You will get some value. Just calculate tan phi value. After getting this, I am using the well-known formula, that is tan phi is equal to √3 times of W1 minus W2 by W1 plus W2. Right. If you observe clearly, tan phi value we are having as well as W1 plus W2 is also available. So automatically we can calculate W1 minus W2 value. So from this you can calculate W1 minus W2. Right. I am coming again. Power factor is given as 0.4. Total power is given as, what is it? W1 plus W2. The moment you see this data, you need to get the idea like W1 plus W2 value is there and he is asking individual wattmeter readings. For that purpose, W1 plus W2 is there means we need to calculate W1 minus W2. That idea you should get. The moment you are getting this idea, yes, you can use this formula and from the given data of cos phi, we have calculated tan phi. And then from this we can calculate the corresponding W1 minus W2. You are going to have 39.7 kilowatt. Just substitute tan phi value, substitute W1 plus W2 equal to 30 kilowatt. You are going to get W1 minus W2 is 39.7 kilowatt. The moment you are getting this 39.7 kilowatt, what you have to do simply, W1 plus W2 is equal to 30 kilowatt and W1 minus W2 is equal to 39.7 kilowatt. But before solving all this, you need to get one more idea into picture. Sir, power factor value is 0.4. Power factor value is 0.4 means less than 0.5. Definitely. If the power factor is less than 0.5, 1 wattmeter reading must be negative. 1 wattmeter reading must be negative. So in that way, you need to observe that 1 wattmeter reading is negative. And if you simplify this, you are going to get that only. W2 cancel. So therefore, 2W1 is equal to 69.7 kilowatt. 69.7 kilowatt. Therefore, W1 is equal to 69.7 kilowatt by 2. So, you are going to get the value of this. This is the final answer W1. Once you are getting W1, substitute W1 in this equation, right? W1 plus W2 is equal to 30 kilowatt. W1 plus W2 equal to 30 kilowatt. Therefore, W2 is equal to, you are going to get the corresponding power. This is the procedure. That's why the moment you see the question, observe the given data clearly. Therefore, you are getting the proper answer. If you are simplifying this, you are going to get W1 as, if you simplify this, what is that? 34 point. You are going to get 34.85 kilowatt, and this will be minus 4.85 kilowatt. So this is the answer, W1 reading as well as W2 reading, right? Next question. The circuit in the figure is used to measure the power consumed by the load. So this is the circuit used to measure the power consumed by the load. Okay, power measurement method. The current coil and voltage coil, nothing but potential coil of the wattmeter have 0.02 ohm and 1000 ohm. Simply 0.02 current coil resistance, right? And 1000 ohm potential coil resistance. Respectively, the measured power compared to the load power will be. He is not asking the corresponding. The measured power compared to the load power will be dash % more. Dash means immediately he is asking what is the error, that error in terms of positive or negative. In that way they are asking. So we need to find out the corresponding percentage error. In order to find out the percentage error, what we require? Right? Measured power we require as well as true power is also required. Now, if you see the given data, directly we can get the true power. Directly we can get the true power. What is it, sir? Voltage across the load is 200. Current through the load is 20 amperes. So therefore, what we can write now? Voltage across the load, current through the load. 200 into 20. So therefore, 4000 watts. So this is the true power. What we require? Measured power we require. Now very simple. What is the procedure for calculating the measured power? If you observe the thing clearly, here potential coil, voltage across this as well as current through this we can calculate. Or we can write here, just I am extending this diagram here like this. This is V, right? And this is anyway I. Now, what is the measured value? Power measured is equal to voltage across the corresponding potential coil, voltage across the potential coil into current through current coil. Luckily, current through current coil is there, 20 amperes is there. But what about the voltage across potential coil? Very simple. Voltage across potential coil is this V. What is this V? Simply this drop plus this one. So therefore, VPC is equal to V is equal to, I am writing V or VPC because this is the potential coil. Voltage across the potential coil is V only. So therefore, V equal to VPC equal to, what is the thing now? This value, what is that? Current into 20 amperes into, what is the resistance of this? 0.02 plus 200. Nothing but V is nothing but voltage. This is VL plus VCC. What is VCC? Current through it and resistance. Now if you simplify this, you are going to get the value as 200, right? What is that? 20 into 0.02. You are going to get 0.4, right? Into or plus 200. 0.4 plus 200. So we are going to get 200.4 volts. 200.4 volts. This is VPC into ICC. So therefore, power measured is equal to 200.4 into current 20. Current is 20. If you are simplifying this, we are going to get 4008 watts. 4008 watts. Right? Now, sir, if you are taking 4008 watts as a measured value and true value is 4000. So simply we can write that. First thing, PM is greater than PT. Of course more, and he has given that dash percent more. So he has given idea, okay, more value is there. Yes, we got it, more only, no problem. Now let us find out percentage error equal to PM minus PT by PT into 100. What is PM? 4008 minus 4000 by 4000 into 100. If you are simplifying this, we are going to get 0.22%. So answer is 0.2. He is asking that dash percent more. So more already we got it. Yes, satisfied. And along with that, percentage value is 0.2%. So answer is 0.2% more. Right? Next question. It is MSQ model question. This is MSQ. Right. Now, it is related to digital voltmeter. If a voltage of 0.6972 volt, what is the value of voltage? 0.69 or nothing but 0.6972 volt is being measured by a 4.5 digit voltmeter. 4.5 digit voltmeter. Then which of the following statement is true or are true? Is or are? It is an MSQ model question. Now the question is, sir, what is the corresponding digit device 4.5 digit? So therefore, we need to understand the basic point like 4.5 digit DVM, 4.5 digit digital voltmeter. Now, in the class also I told you simple technique, 4.5 digit voltmeter. So therefore, right, like this, 4 digits will be there, 4 full digits we say, and 1 half a digit, 4 full, 1 half a digit. In this digit, it allows from 0 to 9, that is, it is called as full digit. Here also 0 to 9. In all these 4 digits, it will be allowing from 0 to 9. That's why those are called as full digits. But here, either 0 or 1. Simple concept I am revising. So 0 or 1. So this is called 4.5 digit. I am writing here, this digit is called as half a digit, and these digits are called as full digits. Full digits. Okay, right. Now, sir, in this, here decimal point will be taken. Here decimal point will be taken. This decimal point is related to 1 volt range. 1 volt range. Okay, and if you are having decimal point over here, this is 10 volt range. Decimal point over here, that will be 100 volt range. Here it will be 1000 volt range. That's what the general idea. If you are talking about extension, so therefore 2 volt, 20 volt, 200 volt, and then 2000 volt. Why, sir? In the 4.5 digit DVM, extension factor is 2. So therefore, 1 volt means maximum will be 2 volt. In that way, I am writing the normal range as well as after extension, what is the corresponding thing. Okay, right. Now, this is the basic idea regarding 4.5 digit DVM. But now, from the given data, how can we choose this option? Very simple. What is the value he has given? 0.6972 volt. 0.6972 volts. So this is the given data. What he is asking? Which of the following is a nothing but my MSQ question. Out of all these 4, which is correct or which are generally more than 1, because it is MSQ model. Observe clearly. 1 volt range, 10 volt range. 1 volt range, 1 means the options 1 volt range is there as well as 10 volt range is there. Now, first thing, on 1 volt range. On 1 volt range means simply take the corresponding digit, with 4 full digits and 1 half a digit. 1 volt range means where should be the decimal point? Here. So therefore, here is the decimal point. Now after this, the simple thing what you have to do is, from the decimal point you start writing. From the decimal point you start writing. Decimal point 6972 volt, and this anyway nothing is a 0. Nothing but on 1 volt range the display will be 0.6972 volt. Now let us verify options. On 1 volt range 0.6972. 0.6972. Okay, so first option is correct. On 1 volt range 0.6972, correct. On 1 volt range 0.697, one number is missed. On 1 volt range 0.69 only. So therefore this is wrong, this is also wrong. So first is correct. Okay, let us verify this next one. 10 volt range. So let us go for second one. On 10 volt range. On 10 volt range. Now in the very simple way, 4 full digits, 1 half a digit, and 10 volt range means where can be the decimal point? Here. 10 volt range means this is the decimal point. Simple technique I am giving. From the decimal point start writing 697. Right? That 2 will not be displayed, no issue. These 2 will be automatically 0. Therefore 0.697. So therefore which is correct? Yes, 0.697. So MSQ. So these two options are correct. Why am I mentioning MSQ? MSQ means generally the moment the first option is matching, people are ticking and going. No, if it is MSQ, more than one option is correct. So select it properly. Right? Next question. The Wien's bridge shown in the figure is balanced at a frequency of nothing but, in this he is asking the frequency value. That too, Wien's bridge is used for measurement of frequency. Wien's bridge is used for measurement of frequency and he is asking that value only. Very simple. If you are able to recollect the formula, just substitution and multiplication division, that's calculation only. But before that I am giving the idea. I am taking this as R1, this as C1, this as R3, this is C2, R2 and this is R4. This is a number we follow generally. So R1, C1, first branch, third branch R3, second branch R2, C2 parallel, fourth branch R4. Now, in the Wien's bridge, what is the formula of frequency? In the Wien's bridge, the frequency formula is 1 by 2 pi root R1, R2, C1, C2. 1 by 2 pi root R1, R2, C1, C2. And in the class we have taken, if these two resistors are same, R into R, R square. If these two capacitors are same, C into C, C square, R square, C square means root will be cancelled. That is the conclusion we have taken. But in this, R1 is not equal to R2 and then C1 is not equal to C2. That's why I am using the basic formula. Over, just substitute all values. 1 by 2 pi into root of, what is R1? 4.7 into 10 power 3 into, what is R2? 10 kilo ohm, 10 into 10 power 3 into C1, 5 nanofarad, 5 into 10 power minus 9 into 10 nanofarad, 10 into 10 power minus 9 over. If you simplify this, you are going to get the value of corresponding frequency. That's why just by observing the figure, which is R1, R2, which is C1, C2, just observe that. After that, simple calculation only. If you simplify this, you are going to get 3.28 kilohertz. Simply, in this way of questions may be possible, direct substitution. But very important thing is remembering this formula. that is F equal to 1 by 2 pi root R1 R2 C1 C2. Right? So answer is 3.28 kilohertz. Next question. 300 volt full scale PMMC meter. So 3 meters are there. Those are having 100 volt as the full scale value. Have the figure of merit. What is figure of merit? Sensitivity. Other name of figure of merit is sensitivity. Sensitivity of 3 meters are given. Sensitivity of 3 meters are given. 3 kilo ohm per volt, 6 kilo ohm per volt, and then 9 kilo ohm per volt. And then the series combination of this is very important. Series combination of these 3 voltmeters can measure maximum voltage up to nothing but after connecting these 3 meters in the series connection, the combination of these 3 meters will be having the measurement capability up to dash. That's what the value he is asking. Now let us analyze this question step by step. Right. So I am drawing the diagram. If you are able to draw the diagram related to the given data, half of the problem will be over. What is it, sir? 3 meters are there. 3 meters are connected in series. 3 meters are connected in series. What they are asking? Maximum voltage, what we can measure with the series combination of these three. That's what the thing. Here, voltmeter 1, voltmeter 2 and voltmeter 3. Right. Now, 100 volt. For everything, 100 volt is the full scale value. All 3 meters are having same full scale value. Next one. The sensitivity is 3 kilo ohm per volt, 6 kilo ohm per volt, 9 kilo ohm per volt. Check it. 3, 6, 9. Okay. Now, just I am making 3 divisions for clarity purpose like this. Right. Now, as 3 meters are there, I am writing as S1, S2 and S3. 3 meters, 1, 2, 3 I am giving. Okay. Now, with these 3, what is the maximum voltage measure? Very simple point. Sir, V maximum means what we require? I maximum into R total we require. Simple. V maximum means what is it? I into R. I maximum into R total we require. So what is I maximum? That is what the biggest task in this. What is it? Sir, from this given data, we can calculate IFSD. What is the relation between IFSD and corresponding sensitivity? Reciprocal. So therefore, 1 by 3 kilo ohm. 1 by 3 kilo ohm. Here, IFSD2, 1 by 6 kilo ohm. Okay. In the same way, IFSD is 1 by 9 kilo ohm. Now the question is, sir, this is the meter having the full scale value of 1 by 3 kilo ohm. This is having 1 by 6 kilo. This is having 1 by 9 kilo. The biggest task is, sir, with this combination, what can be the maximum current possible? With this combination, what is the maximum current possible? Means whatever the minimum current is there, that will be the maximum current flowing to this. Why, sir? Very simple. Suppose 1 by 9 kilo ohm of ampere current is flowing. Yes, this meter will be safe, this meter will be safe, and this is also safe. Means all meters are safe. But if I am sending 1 by 6 kilo ohm current through this, it will be safe, it will be. But 1 by 6K will be more than this one. This instrument may be damaged. That's why, see the question clearly. The series combination of the voltmeters can measure a maximum DC voltage equal to. So therefore, whatever the minimum full scale value is there, that itself is the maximum allowed current. So therefore, what is the value? 1 by 9 kilo. So therefore, I maximum is 1 by 9 kilo. 1 by 9 kilo. right? And if you want to have more clarity, 1 by 3, 0.33 milliampere. 1 by 6, right? 1 by 6 will be automatically what is that? 1 by 6 means, or we can take 10 by 6, right? 6 ones are after that 4 will be there, 6 5s are 6 6 are 36, like that. Approximately I'm rating 0.16 milliampere, but here 0.11 milliampere. Don't get confused. Similar model question we have taken in the class also. The question is 0.33 milli looking like more value. Yes, that is true. It is a more value. But we don't want among these three which is the more value. No. What is it? This combination allows which current has the maximum current. That is what very, very important. So that's why simply I am giving one simple analysis. I am sending 0.11 milliampere through this, for example. It is having the capacity up to 0.33 milli, so it is safe. 0.16 milli means it is safe. 0.11 milli means all will be safe, okay. But if I am sending 0.16 milliampere, for example, somehow I am sending, it allows up to 0.33 milli means it will be safe. It allows up to 0.16 milli means it will be safe. But this allows up to 0.11 milli because it is a full scale deflection, means full scale capacity of that. That's why instrument 3 will be damaged. That is the reason why with all these discussions, which current is a maximum allowed current means among these three, whichever the less full scale value, that is a maximum. That's why written 1 by 9 care 0.11 milli. Okay, after that. Now, sir, what is the resistance of this one? What is the resistance of? Simple. 3 kilo ohm per volt into 100 volt. 3 kilo ohm per volt into 100 volt. Volt will be cancelled. So therefore, what is the value? Right? 300 kilo ohm. Here, R2 equal to 6 kilo ohm per volt into 100 volt into 100 volt. So therefore, what is this? 600 kilo ohm. And here R3 is equal to 9 kilo ohm per volt into 100 volt. So this will be 900 kilo ohm. 900 kilo ohm. Now, what is the total value of resistance? 300 plus 600, 900 plus 9, 1800 kilo. So therefore, 1800 kilo ohm. 1800 kilo ohm. So therefore, kilo will be cancelled, 9. So simply 200 volt. This is the maximum value, right? What is it? Kilo will be cancelled, 9 2s. So automatically what is it? 200 volt is the maximum value measurable. So therefore, here if I am taking this as 1 by 9 means 0.11 etc. It may be like 199 point, otherwise no problem. It is 199.8, or if you are taking the as it is value 1 by 9 kilo, yes, it will be 200 volt. So answer is 200 volt is the maximum voltage measurable by that entire series combination of 3 meters. Right? Next question. A voltmeter of 0 to 100 volt has a sensitivity of 20 kilo ohm per volt. E is connected across 20 kilo ohm resistor as shown in the figure. Okay, across this 20 kilo ohm, the corresponding voltmeter is connected. Okay, the percentage error is dash. Always percentage error means AM minus AT by 80 into 100. If you observe this, what is the voltage across this true value? We have to calculate. What is the voltage measured? We have to calculate. Then we have to go for corresponding error. Now, what is it, sir? I am redrawing the diagram, right? This is 100 volt. 100 volt, and this is 80 kilo ohm, and this is 20 kilo ohm. Now, I am not connecting any voltmeter, simply I am finding the voltage. If I am finding the voltage directly, that will be the true value. So therefore, V true. Now, what is V true value? V true is equal to, what is that? Total voltage into 20 kilo by 20 kilo plus 80 kilo. 100 kilo, this 100 will be cancelled, kilo will be cancelled, so automatically the voltage will be 20 volt. Okay, true value of voltage is 20. Now, this is the first step. Now, the second step will be measured value calculation. How, sir? This is 80 kilo ohm and this is 20 kilo ohm and this is 100 volt. Okay. But in order to find out the measured value, we need to connect the voltmeter. And in the question, he mentioned clearly, this is the voltmeter connected across 20 kilo ohm. So therefore, across this I am connecting. Now, what is the full scale value? 0 to 100 volt. 0 to 100 volt is a full scale value. What is the sensitivity? 20 kilo ohm per volt. Now, if you want to find out the voltage across this, nothing but voltmeter reading itself is the measured value. Just I am writing Vm as this. In order to find out that value, what we require? Resistance of the meter we require. So therefore, the meter resistance is 20 kilo ohm per volt into 100 volt. So what can be value now? 20 kilo and 100 means 2000 kilo, means simply this will be 2 mega ohm. That will be 2 mega ohm. I am redrawing the diagram just for clarity purpose. Here, this is 80 kilo ohm. This is 20 kilo ohm. Across this, meter is connected with the earlier data, that is, what is that? Full scale value and sensitivity. What we have calculated? But resistance of the meter, that is 2 mega ohm. 2 mega ohm is connected, right? And here this is 100 volt and this will be the measured value Vm. This will be the measured value Vm. Now, let us find out Vm is equal to total voltage is 100 into, now very important thing is Vm is not only across this, across the parallel combination. That's what very important. So that's why what we can write now, 20 kilo ohm parallel with 2 mega ohm by 20 kilo ohm parallel with 2 mega ohm plus 80 kilo ohm. Right? If you simplify this, you are going to get the corresponding measured value of voltage. What you have done? See this clearly. Across this voltmeter is connected means without the voltmeter, what is the voltage across it? That is a true value. With the connection of voltmeter, whatever the value, that will be the measured value. You are going to get the measured value as 19.83. 96 something volts. Okay. But what he is asking? Percentage error they are asking. Percentage error. So simply percentage error is equal to AM minus 80 by 80 into 100. Now, substitute that value 19.83. 19.83 minus true value is 20 by 20 into 100. So, you are going to get the corresponding value. Right? For your idea purpose, I have shown already, yes, this is the error, that will be 0.8%. Clear? Only what you have to do? True value you have to calculate, then measured value. Measured value plays a role with calculation of meter resistance. Yes, further data is given. Observe this properly. Clear? So, error will be correspondingly minus 0.8%. Right? Next question. V is equal to 100 plus or minus 4% volts. I is equal to 50 plus or minus 3% amperes. I told in the class, the moment you see the errors, don't be in hurry in calculating the resultant. Observe the type of error compulsory. What is it? Errors are given in standard deviation. Errors are given in standard deviation. Therefore, what he is asking? The value of standard deviation of power is. So, they are asking power. In that power, what is the standard deviation value? Kindly focus. Here, V is equal to 100 plus or minus 4% volts. I is equal to 50 plus or minus 3% amperes. Okay. What they are asking? Power. Sir, power is equal to, what is it? V into I. So, true value always same, no problem. Multiplication is just simply you multiply. So, therefore, I am writing like power true is equal to voltage true into current true. What is voltage true? 100. What is current true? 50. So, therefore, what is the value? 5000 watts. This is a true value. But what they are asking? Standard deviation in the power. So, what is the procedure? Standard deviation in the power. Right. We know that corresponding procedure, P is equal to V into I. I told in the class this method. What is the voltage to the power? 1. So, therefore, 1 into. What is the voltage related percentage error? 4. 4. Keep the percent outside. Yes, square plus. Okay. What is the I power? 1 into. What is the current error? 3. So, 3% square. So, therefore, what is the value now? 4 square, 3 square. So, simply you are going to get 5%. But problem with this question is 5% is there. This is which one? NAT, numerical answer type. Don't give 5% because he is not asking in percentage, he is asking in watts. He is asking in watt. That's why after calculation of this, power is equal to 5000 plus or minus 5% watts. Okay. But what he is asking, observe this clearly, with the same procedure, similar model, earlier paper question is also there. In that they asked, resistance is in terms of ohm, standard deviation of resistance in ohm. But if you use this procedure, you will get percentage value. That percentage must be converted into value form of resistance in that previous question. In this, I am giving in terms of power. That's why this 5% must be converted into value form. So, that's why 5000 plus or minus 5% of 5000 is 250. So, therefore, according to the given question, which is the answer? 5% is not the final answer. 5% may be correct, but that is in terms of percentage. But he is asking in terms of watts. So, that's why answer must be 250. You have to type 250 number compulsory. If you are giving 5, it looks like 5 watts. But is it 5 watts? No, it is 5% of 5000. That's why see the question clearly. Don't think like, this is the question solved in the class, so I can hurry. No, don't do that. See the question from starting to last. He is asking in terms of watts. Therefore, answer will be 250 watts. Right? Next question. The DC current flowing in a circuit is measured by 2 ammeters. 2 ammeters are there. They are measuring the DC current. One is a PMMC. Other one is electrodynamometer instrument. One is PMMC, other is electrodynamometer. Connected in series. Okay. The PMMC meter contains 100 turns in the coil. Flux density is 0.22 Weber per meter square. And the area of the coil is 80 mm square. In the PMMC, complete data is given. Number of turns are given. Flux density is given, and then area of cross section is also given. Okay. The electrodynamometer has a change in mutual inductance with respect to deflection. Nothing but dm by d theta is given. Okay. The spring constant of both meters are same, means Kc of PMMC, KC of dynamometer, both are same. The value of current at which the deflection of the 2 meters are same, nothing but the deflection is also same, nothing but theta of both also same. Therefore, corresponding current is a dash. What is the data? Simple. Question looks like lengthy, but if you read the question clearly by spending few seconds of time, thing will be very, very easy. What is it, sir? First, deflection of 2 meters are same. Okay. Theta of PMMC is equal to theta of EMMC, means dynamometer type instrument. I'm writing EMMC. What is theta formula? BIN into A by KC. What is theta in the dynamometer? I square by KC into dm by d theta. If you are able to recollect the formula, yes, thing will be over. Just substitution and calculation only. Sir, KC cancel. 1I will be cancelled. So therefore, the remaining equation I am writing, but what we are supposed to find out? Current, no? So therefore, I am keeping current I is equal to, I am bringing this to this side, BN A by dm by d theta over I is equal to, I am bringing this side, BN A by dm by d over. Substitute all given values. B, what is B? 0.2 into number of turns 100 into area 80 mm square, nothing but it must be converted into meter square, 80 mm square, right, divided by, what is this value? 0.5 milli. 0.5 into 10 power minus 3. Okay, right. Now very simple, don't make it lengthy calculation. 10 power minus 3 going upside, 10 power 3, 1, 2, 3, 10 power 6 is cancelled over. And then 0.2, point will be cancelled. 2 into 8, 16 by 5 over. 16 by 5. 5 3s are 5 2s are 3.22 amperes. So you have to give the answer as 3.22 amperes. That's why I told in the class, I repeatedly say that if the question is lengthy, don't skip it, right? Just go through the data. Some hint will be there. KC is equal, theta is equal. From that only you have to start. So therefore, see, last line should be the starting step in the solution. In that way, read the complete question compulsory. Answer will be 3.2 amperes, right? Next question. It is also, right, MSQ model. The moving coil in a dynamometer wattmeter is, what is it he is asking? The moving coil in a dynamometer wattmeter is dash. Sir, moving coil means in the dynamometer wattmeter, the moving coil is nothing but potential coil. You need to recollect this. Moving coil nothing but potential coil. Potential coil must be dash. That's what he is asking. With high resistance, yes, potential coil resistance is always high, yes, correct. Connected across the supply, yes, correct, nothing but potential coil must be in parallel, yes, what is that? Across, so therefore it is also correct. With low resistance, no, wrong. In series with the load, wrong. So automatically out of 4, 2 are correct here. This is potential coil or moving coil must be high resistance and connected across the supply. Actually, connected across the supply or connected across the load also based on MC short or LC short connection. But only one is given correct. But here series is given wrong. Low resistance is given wrong. So that's why out of 4, 2 are correct. Right? Next question. Power consumed by a balanced 3-phase 3-wire load is measured by the 2 wattmeter method. 2 wattmeter method is used. The first wattmeter reads twice that of the second. First wattmeter reads twice that of the second. The load power factor angle in radians is, he is asking what is the power factor angle in radians. So what is it? Simple. Here no. What is the corresponding power factor formula? Before that, what is the relation? One wattmeter reads twice that of the other. So simply assume that W1 is equal to 2W2. Just one is twice that of other. Therefore, W1 by W2 is equal to 1 by 2. Right. Now, what is the power factor formula? Cos phi is equal to cos of tan inverse root 3 W1 minus W2 by W1 plus W2. Right? Now, simple. Cos of tan inverse, right? Root 3 W1 minus W2. What is W1? 2W2 minus W2 by 2W2 plus W2. Now, sir, this is W2, this is 3W2, W2 will be cancelled, root 3 by 3, 1 by root 3. So, what is the remaining one? Cos of, what is it? Tan inverse root 3 by 3 means 1 by root 3. Cos of tan inverse 1 by root 3, 30. So therefore, cos 30 is nothing but cos phi. What he is asking? Load power factor angle. So therefore, what we can write now? Phi is equal to 30 degrees. He is asking radians, no. So therefore, simply pi by, what is that? Pi 180 by 6. This is the answer. Right? So 30 degrees or simply pi by 6. If it is the corresponding thing based on the degrees or radian, choose the corresponding option in the question. Right? Next one. An energy meter connected to an immersion heater resistor operating on 230 volt 50 Hz AC single phase source reads 2.3 units. For idea purpose, unit means kilowatt hour is also given. Safe said, no headache at all. And 1 hour of time. The heater is removed from the supply and now connected to 400 volt peak to peak. Very, very important. It is not peak value, it is peak to peak. The two square wave source of some frequency. The power in kilowatt dissipated by the heater will be the power in kilowatt dissipated by the heater. Very simple. According to the first statement, what is that? 2.3 kilowatt hour. 2.3 kilowatt hour is equal to, what is that? Power into time. What is the power? V square by R into time. Nothing but power. Why we are taking means 230 volt voltage is given. With this is the energy rate, this is the voltage given to the heater, this is the resistance of heater. So with this data we can calculate resistance of heater. Now, sir, this is in what? This is in hours, watt hour. So therefore I am converting 2300 watt hour is equal to V square by R into T, so many watt hours. So equation is balanced. Now, sir, what is this? R is equal to V square by 2300. What is V, sir? 230 square by 2300. Don't make it complicated like 230 square multiplied, don't cancel. Simply 230 into 230, right? 2 zeros and 123 will be cancelled. So directly 23 ohm. Always save the time, at least in few calculations. Okay, this is the resistance of heater. We got it, okay. After that, it is disconnected or removed from that and connected to 400 volt peak to peak square wave source. Very important thing. This is the square wave. Here to here 400 volt, that is peak to peak. So what is a peak value? 200. If you substitute 400 without reading this data, answer will be wrong. So that's why peak to peak is 400. Peak value is 200 only. Peak value is 200. Then what is the power dissipated? Very simple. Now power is equal to V square by R. What is the V value? Yes, peak value, that is 200 square by what is the resistance of heater from the first data we calculated? 23 over. That is what very important thing. From the first data, resistance of heater must be calculated. From the second data, we need to observe that peak to peak is given. We have to observe peak value and then correspondingly power consumption V square by R. If you simplify this, you are going to get 1.73 kilowatt. So answer will be 1.73 kilowatt. Right? Next question. In a low power factor meter, in a low power factor wattmeter, the compensating coil is LPF wattmeter, compensating winding is connected. Right? So without reading all these options, let us recollect the thing. In the low power factor wattmeter, compensating coil is connected in series with the potential coil to compensate the power loss occurred in the corresponding potential coil. That's it. No, check it here. To neutralize the capacitive effect of the coil. No. Capacitive effect. No. To compensate inductance effect of the pressure coil. No. To compensate the error caused by the power loss in the pressure coil. Correct. And don't go to the next, it is MSQ model. Yes, I am giving the idea, right? MSQ, right here. E is connected, compensating coil is connected in series with the potential coil, correct? So therefore, answer will be C and D. Answer is C and D. Out of 4, 2 options are MSQ model, right? Next one. The 2 wattmeter method produces wattmeter readings as P1 equal to 1500 watt, P2 equal to 2500 watt. When connected in some connected load, okay, delta or something, no issue. The per phase reactive power E is dash VAR. If the line voltage is 220 something is given. Be clear. He is asking per phase reactive power. Per phase reactive. So for that purpose, what we require first? What we require? 3-phase reactive power we require. 3-phase reactive power formula is √3 times of W1 minus W2 or W1 difference of W2. This is a total thing. Now what is that? √3 times of, what is W1 difference of W2? 2500 minus 15. What is that? Large minus small always. So simply 1000. This is a 3-phase power. But what he is asking? Per phase reactive power. What is that? Q 3-phase by 3. Simple. Q 3-phase by 3. So therefore, what is that? 1000 √3 by 3. What will you be getting? 1000 by √3. 1000 by √3. If you simplify this, you are going to get 577.3 VAR. 577.3 VAR. Simple. But don't stop here. 100 √3 don't substitute because he is asking per phase, not the total 3-phase reactive. That's why first get the 3-phase total reactive and then by 3 will be the per phase. So therefore answer is 577.3 VAR. Right. Next one. Very simple question. A set of independent current measurements taken by 4 observers were recorded as. So 4 readings are taken. They are asking like range of error is a dash. So what is it? Range of error. Range of error in terms of milliampere. So what is it, sir? Milli is given. He is asking milliamperes only. What is the range of error formula? Range of error is equal to maximum minus minimum by 2. Among the given data, take the maximum and take the minimum difference of those two by 2. Very simple. What is the maximum value according to given data? Yes, 117.11 minus, what is the minimum? 117.02 by 2. You will be having 0.09 by 2. So therefore 0.045, of course, milli is the answer. So what would be the answer? 0.045 milliamperes. Right? Next question. When reading is taken at half scale in the instrument, the error is dash. Reading is taken at half scale. So before seeing the options, let's have the corresponding thing. Let's have the thing like, sir, this is 0. This is a full scale value. Assume that yes, this is the half of a full scale value. Now, where they are taking the reading? At half full scale. At half scale they are taking. Okay. Sir, we know that one principle. If you are going towards the full scale value, error will be less. So therefore, what is that? Here, error is less. Here, error will be more. Towards this, error will be further more. That's what the idea we know already. Towards the 0, error is more. If you are moving towards the full scale value, error is keep on getting reduced. If you are able to recollect this concept, you can answer this very easily. Let us see the first option. Exactly equal to half of full scale error. Exactly equal to half of full scale. Actually, more than the full scale error. So therefore, wrong. Equal to full scale error. No, more than the full scale error. Wrong. Less than 1/4 full scale error. Less than 1/4 full scale. So where is the 1/4 full scale? Let me take, this is 1/4 full scale value. What will be the error? Error at half full scale will be less than this one. Why, sir? If I keep on moving this side, error is keep on getting reduced. Therefore, quarter full scale value error is more than this. So therefore, this is half full scale value error is less than this. Correct? Right. Next one. More than full scale error. Yes. Compared to full scale error, it will be more. Correct? So therefore, yes, options are C and D. It is also MSQ model. Multiple select questions. So these are the questions related to this entire series. Those are, right, score booster series, and I have covered few NAT questions and a few MSQ model questions. Right. So this is the total session regarding the NAT and MSQ model questions. And finally, right, wish you all the best. Thank you.